Getting into the air pollutants that are most harmful for human health. And these are, in fact, monitored by the EPA in the United States. So the EPA is the Environmental Protection Agency. And this is the EPA for short. The EPA has existed since about the 70s. It was a law called the Clean Air Act that set standards for air quality and for these air pollutants like carbon monoxide, sulfur dioxide, nitrogen dioxide, ozone, and particulate matter, set standards and also set a regulatory agency, the EPA, to monitor those standards. So we have that in the United States. Not all countries have this type of governmental regulation, so we're lucky that we do. We're also kind of dependent on who the president is, because this is determined, who heads the EPA is determined by the president. So in carbon monoxide, sulfur dioxide, nitrogen dioxide, and ozone, these are all gases. These four are gases. And particulate matter actually can be solids, very small solids that we can't see, and liquids, also very small liquids that we can't see. So particulate matter are solid particles and small liquid droplets, and the one we'll be focusing on is most important, particularly for wildfires, as PM 2.5. One atom of each is from incomplete combustion reactions. So this is a combustion reaction that's an example, would be just burning wood. So when you burn wood or when you burn gasoline, we'll get into combustion reactions, but the process of burning. There's a side reaction. So the main reaction in the process of burning is you burn a hydrocarbon and generate carbon dioxide and water. But a side reaction generates this product in small amounts, carbon monoxide. And this is an odorless and colorless gas. So you can't see it, you can't smell it, but it is a silent killer because accumulated amounts will displace oxygen in your blood, attach to hemoglobin, and displace the oxygen. And when there's 50% or more oxygen displaced, this will lead to lethal. It's lethal. So you can reverse the effects of carbon monoxide displacing oxygen by removing yourself from that carbon monoxide source. And so this is something that is reversible. So when you walk away from the carbon monoxide source, you can recover. But the biggest problem is from cooking fires that are indoors, and we'll get to that as an indoor air pollutant, that you need ventilation for any combustion reaction, whether it's a cooking fire or a car exhaust. You need to ventilate and have that out. And so the carbon monoxide produced in small amounts doesn't accumulate. This is also combustion. On cigarette smoke, carbon monoxide is generated. That a smoker will exhale about 20 to 50 parts per million carbon monoxide in their cigarette smoke, and this is compared to about 2 parts per million from non-smokers, just regular exhalation. Carbon monoxide comes from combustion reactions, and this is combustion of hydrocarbon is most common, and it's going to be coming out of car exhaust. The majority of car exhaust is carbon dioxide, but you're going to get some small amounts of carbon monoxide. So this would be the main reaction. This is a hydrocarbon. This is actually octane, C8H18. We'll get more into combustion reactions of hydrocarbons, but it combines with oxygen in the air, and this is in an engine that is an internal combustion engine that burns gasoline. and this generates the majority as carbon dioxide, and then also water. And that's so hot that it comes out as steam. So that's a complete combustion reaction. But the small amount of carbon monoxide is from incomplete combustion. So the same octane in the gasoline engine has this side reaction that generates some carbon monoxide and also water. Okay, so this is also occurring in the reaction where you're burning any hydrocarbon. So this can be wood, or it can be methane, a natural gas, or it can be candles. But the most common are going to be talking about car exhaust. Sulfur dioxide, SO2, is a byproduct of coal-fired power plants. Now that's a long term. So coal-fired power plants are used for generating electricity. And this is electricity for the grid, large-scale amounts of electricity. We'll go into in chapter 6 all different ways that electricity is generated, but coal-fired power plants are the most common way of generating electricity in every country in the world. So this is burning coal, and this is coal that generates heat, and then the heat is used to basically move steam through a turbine and generate electricity. And this is for the grid or public use, so large amounts of electricity. But it also happens in factories. So factories burn coal to generate electricity at the site, and this also generates lots of this air pollutant, sulfur dioxide, whether you're generating electricity for the grid or at a factory, you got SO2. SO2 is a gas that is colorless, mostly colorless, but it is also very smelly. It does have an odor. So unlike carbon monoxide that was odorless and colorless, this sulfur dioxide, you'll know that it's around, so you could remove yourself from that situation. Coal-fired power plants are the primary producer of sulfur dioxide. So that's that SO2. And coal-fired power plants, this is an example of one down here, this is either generating electricity for the grid or electricity for the grid, that's large-scale amounts of electricity, such as the electricity we get in our homes, or factories, just generating electricity at a factory on site. And so this is what you'd have for either. And you can see all this stuff coming out. So this white stuff, which you could generally call smoke, what it is a mixture of water vapor. It's mostly water vapor. Okay, so that's harmless. So that's the thing. If you're standing next to this factory, you don't have to be thinking, oh, this is toxic. This is mostly just water vapor, steam, like when you boil water. There's also lots of carbon dioxide. So this is CO2. And there's smaller amounts of sulfur dioxide, that's SO2. And then even smaller amounts of nitrogen dioxide, NO2, and also some particulate matter, PM. But the main product of the coal-fired power plant, so the main product of a coal-fired power plant from an air pollutant perspective is this sulfur dioxide. So it produces large amounts of water and carbon dioxide, but sulfur dioxide is an air pollutant, and water and carbon dioxide are harmless from an air pollutant standpoint. There's also nitrogen dioxide and particulate matter, but this is the main source of sulfur dioxide. So sulfur dioxide, as I mentioned, is colorless, but it is very smelly. It has a strong odor. Nitrogen dioxide, or NO2, is a byproduct of engine exhaust. So this is your standard gasoline combustion engine. This is most cars, standard cars that you put in gas or gasoline. There's a combustion reaction that goes on, and This is a hot engine. Inside of that hot engine, where gasoline is burning, and it's a series of little explosions that cause the pistons to move up and down, and that cause the drivetrain to roll in a standard car. This is going to be hot, and there's a side reaction that produces NO2, and NO2 is a brown gas. It's usually called smog, what we think of as smog, and it is also very smelly. So it does have a color and it does have an odor. Engine exhaust is the primary producer of this nitrogen dioxide, this brown smog. And this is a reaction that is a side reaction inside of a hot engine. And so it doesn't happen in cool engines like electric powered cars. So it's the gasoline combustion. And the side reaction takes nitrogen from the air. It's N2. Remember, that's the majority of gas in our atmosphere is 78% nitrogen, N2. And it reacts with O2, also from air. And it's just because of the heat in the engine that this reaction happens and produces NO2, or NO. And then this NO then continues to react with oxygen, also from the air. And this ultimately produces this air pollutant, nitrogen dioxide. And this comes out of the car exhaust in the tailpipe of the car. Okay, so we have the smog is basically this brown layer. This is Salt Lake City, and it is something that you can actually see. And in this case of Salt Lake City, it's actually trapped closer to the surface compared to up here. You have clear air due to what's the effect called an inversion layer, which we also have in Los Angeles and particularly in the Valley or Riverside County. So nitrogen dioxide comes from this engine exhaust. This is showing the molecular views. So we have nitrogen is N2, oxygen is O2, this is blue, and oxygen is red. And we get the reaction producing two molecules of NO. And then those molecules, or we could shorten it to NO, those molecules of NO, this is an NO, this is an NO, and this is an O2, react and form two molecules of NO2. So this is a nitrogen bonded to two oxygens, and there's two of them. So the reduction of NO2 in the last 40 years or so has been due to catalytic converters that are added to cars, required by the EPA, the good old Environmental Protection Agency. And that's why you have to get a smog check on your car. So regular smog checks are required for vehicle registration. And this is to check the amount of nitrogen dioxide released, and sometimes it's due to needing to replace a catalytic converter. Or about air inversions. So this is an example of a valley with mountains on either side, like Salt Lake City or Los Angeles or Riverside County. Warm air generally rises, okay, and the cold air stays down below. And this happens, and air constantly circulates. Warm air goes up, replaced by cold air, and this is a natural process that circulates and clears out air. Air mixes and cleans itself. Okay, so, but it depends on the geography. So in cases like this where you have a valley, this colder air stays trapped down below. And this is called an inversion layer. So this inversion layer happens here too in Santa Monica. When, for instance, we have had a marine layer this week, and what's trapped in it is not just the cold air, but this also traps air pollutants. So this also worsens when the airflow is limited. This is due to mountains. So there are cities surrounded by mountains. So this is the case in the valley Riverside County, and sometimes even the West LA, when we have that marine layer, will trap air pollutants. So these last two, ozone is a gas, and particulate matter, those are solids or small liquid droplets. Ozone is created at ground level and the troposphere in a chemical reaction. And that ozone created in the troposphere is a chemical reaction that requires NO2 or SO2 to start with. So you need one of these other air pollutants. These are called primary air pollutants. And these are used to produce ozone, which is a secondary air pollutant. Basically, it means you can't have ozone unless you have these others to start with. Okay, so you start with one of the primary air pollutants, either NO2 or SO2, and sunlight. So you need sunlight, specifically UV energy from the sun, and these two together will create ozone, a secondary pollutant. So if you have only sunlight, that's not going to do it. So ozone is the most harmful for human health compared to the carbon monoxide, sulfur dioxide, and nitrogen dioxide, and this is the one that is the biggest determinant. All right, the biggest determinant of air quality. Okay, and I'll add to it, I'll qualify that most of the year. It's the amount of ozone most of the year that determines whether it's a red day or a yellow day or a green day. But for some parts of the year, particulate matter, particularly PM 2.5, is actually the biggest determinant of air quality on certain days of the year when there are wildfires and smoke. And these are small particles that are truly very harmful to human health, and we'll get to that. So ozone is toxic to living things even at low concentrations. And it's around most of the year. Compared to wildfires, there's a certain season that we have wildfires and smoke. But when humans breathe in ozone, it causes chest pain, it causes coughing, the lining in the lungs will break down, and this is all temporary because your body, your cells can regenerate. Or O2 is necessary for life. Okay, so ozone is just one more oxygen added to that, O3. Ozone is toxic to life. And this is also split though. There's ground level ozone, this is in the troposphere, is toxic. Okay, it can have these negative effects on health, irritating your mucous membranes, shortness of breath, can lead to asthma attacks. These are sensitive groups of people with asthma. They're called sensitive groups. In the air quality index, when it says the air is unhealthy for sensitive groups, they're usually referring to people who can have asthma, but also with compromised immune systems and other health issues. But generally asthma is going to affect most people. So, but we'll see in the next chapter, in chapter 3, that ozone in the stratosphere, so that's way up in the one of the upper regions, or the next higher region of Earth's atmosphere, is the stratosphere. So that's above 30,000 feet. This is necessary for life. And this is for all life on Earth. That ozone up in the stratosphere protects all life on Earth, including us, and so we need it up there. So this ozone being a secondary air pollutant, this is a reaction of nitrogen dioxide, like NOx, this would be NO2, or you could have sulfur dioxide. NO2 comes from automobiles, sulfur dioxide comes from coal-fired power plants. You can also have volatile organic compounds starting this up, but let's just go for the NO2. And when you have sunlight, sunlight contains energy, particularly the UV energy, initiates reactions that generate ozone. This is O3. Okay, so literally these air pollutants kind of bake due to the exposure to sunlight, but ozone is only generated in the presence of sun. Okay, so that means that we only have ozone produced during the day. This is basically the hours between 10 a.m. and 5 p.m. Okay, so ozone is only produced in sun, and during the highest hours of sunlight, and it's mostly during the summer months, or can be higher during summer because there's more sun, more intense. Okay, it's not a heat thing. It's simply how much sun there is. Like certain states, depending on where you are on the globe, have less sun, and also depending on being closer to the equator. So it also depends on the region. So again, it's not heat, it's just having more intense sunlight, and more intense sunlight will have more of these reactions with the primary air pollutants to generate ozone. They are particulate matter is classified by size, and I mentioned that 2.5 is this biggest determinant of air quality. And when you have a red day or a purple day or a maroon day, that's usually because you have high amounts of PM 2.5. So there's PM 10 and there's PM 2.5. Both of these are, the numbers are indicating the diameter of the particles. So this is a 10 micrometer diameter versus PM 2.5 is a 2.5 micrometer diameter. So whether it's a solid particle or a small liquid, this is the 2.5 smaller, and the smaller the particle, okay, 2.5 is smaller than 10. The smaller the particle, the more likely that this, when inhaled, can pass through, go into your lungs and then pass into the bloodstream and cause long-term effects. So the PM 2.5 can pass into the bloodstream, and that would be the problem with inhaling PM 2.5 from wildfires. So, but particulate matter is not just this from wildfires, can also be larger PM 10, and that would be dust and pollen. That you can even see dust and pollen. Oh yes, wildfires are the biggest issue for releasing PM 2.5. What we see here is this black stuff, which is soot. So this is when you are dealing with that. I highly recommend looking at purpleair.com or also airnow.gov or the newspaper to check air quality. And we'll go into what the recommendations are for air quality, but basically green day, yellow day, those are good air quality days, and orange is unhealthy for sensitive individuals, and then anything above orange, so red, maroon, purple, those are all unhealthy for all, and those are days that you should stay inside and try to avoid breathing in this stuff.